Welcome to classes on structures of atom. Higher secondary first year, and it is the continuation of class number 19. And the last class we have done up to Dalton's atomic model to spectra of hydrogen atom. And today we will come discuss about Plum-Parding, Thomson model of atom or watermelon model. And this thing is very simple and no elaborate discussion is required, where it is stated that the positive charge inside the atom is uniformly distributed and electrons are embedded in it. Simple one line theory. Very simple concept. Likewise, just watermelon, the pink part and seed, the positive charges are uniformly distributed and which the electrons are embedded in it. This is the simple theory of Plum-Parding Thomson model of atom. But the drawback of this one is very important. It cannot explain the spectra. Drawback. It cannot explain the spectra in hydrogen atom or in other atoms. Number 2, it cannot explain alpha particle scattering. Hence, this theory is up to this, and later on came forward Rutherford. And next model of atom is Rutherford atomic model. This is very important, and lots of very valuable information is contained in this model, and you will be too much helpful in understanding the atom chapter of physics in higher secondary second year if you have profound knowledge on Rutherford atomic model. Rutherford atomic model, before giving the atomic model, Rutherford did an experiment along with two of his associates, and he did the experiment with the alpha particle, means it is this, and a gold foil of thickness 10 to the power 4 millimeter. So let us first explain his experiment, and out of which he drew some observation, and basing on the observation he gave some conclusion regarding the structure of atom. So what was his experimental setup, and what was his observations, and what were his conclusions, or what was his conclusions. This is the experimental setup in which he did what? The circular part is nothing but the gold foil, and thickness is very thin, of the order 10 to the power minus 4 mm, and he allowed to pass alpha particle or helium 4 positive. This is alpha particle, positively charged particles. This alpha particles was derived from barium, and this from the barium, this alpha particle, positively charged particle, was made to bombard through the gold foil of thickness 10 to the power minus 4 m. and he found some observations, and out of these observations he inferred some of the facts regarding atom, and that is nothing but the Rutherford atomic model. Now let us find what was his observations. Observation number 1, maximum of the alpha particle radius which are positive in nature, pass straight to the nucleus, to the atom. Maximum of alpha particle pass straight, and some of the alpha particle deviate with angle greater than 90. Some of the alpha particle deviates with some angle, scattered with some angle greater than 90. And observation number 3, very little alpha particle, whenever it is made to bombarded, and when it strike, it comes back to its original path. Means some of the alpha particle retreats back to the original path. Some of alpha particle retrace back. It is of the order 1 in 1000, 1 in 10,000. Out of 10,000, one alpha particle retrace back in this way, means 180-degree angle. Am I right? Fundamentally, there were 3 observations in the Rutherford alpha particle scattering experiment. Now, out of these 3 observations, what he inferred is that inference or conclusions. From first observation, it was found that maximum of the alpha particle pass straight means that the atomic inner atomic space of an atom is empty. That's why without deviation, maximum of the rays alpha particle pass straight without deviation, means the spaces inside the atom is maximum space empty. Number 2, now when it is found that some of the alpha particle deviates with some angle, it doesn't pass straight, it deviates with some angle, it means that the particle which was made to pass through the gold foil was positive, and somewhere inside the nucleus there must be some positive charge. That's why positive and positive get repelled, and hence there is a repulsion of this charge, means inside this atom there must be some positive charge. And some of the alpha particle retrace back means the center of the alpha atom is a condensed one. Whole mass of the atom is concentrated in the center. Means all the mass of an atom is concentrated in the nucleus and it is very dense. Hence, when alpha particle directly targeted to the center cannot penetrate, pass out through the atom, it retraces back, and later on it was turned as nucleus where proton and neutrons are there. So this is in short. And another important point is that in his observation, and lots of other observations are there. For your understanding, I have given you only 3. Another, alpha particle scattering is perfectly elastic collision. means here mass momentum and energy is conserved. Am I right? So another lots of things are there in physics. You will get it. I have done the class of alpha particle scattering in a very explicit manner in the physics science in the second year. Please go through this chapter number 3. I think class number 3. You please proceed. You can find a lot of things in this. When combined, if you learn, you can learn a lot. So this is all about the atomic model of Rutherford with the help of the Rutherford alpha particle scattering experiment. Now comes, whenever there is a model, then and then arises, are there any difficulties at the drawbacks? Yes, there are drawbacks or loopholes. Now you see, it cannot explain the extra stability of atom. So now it can the first drawback is that it cannot explain the extra stability of an atom, means according to classical physics or the Maxwell's electrothermodynamics electrothermodynamic concept, when a charged particle revolves under the influence of another charged particle, here positive charge means proton is there, electrons is revolving. Am I right? Positive charge means proton inside the nucleus, proton and neutron chargeless, electron is negatively charged particle. This is charged particle revolving around the another charged particle means proton. Then during its revolution, the charged particle will continuously emits out energy, and thereby the path of revolution will decrease, and ultimately a time will come it will fall upon the nucleus. And it is well calculated that if these things happens, the electron would have fall upon the nucleus within 1 by 10 to the power 8 second. Very small interval of time it would have fallen on the nucleus. But such things are means atom would have not existed. But in practice we see atoms are existing, means it is not happening. Electrons are not falling on the nucleus during its revolution. Means why this is stable? If it is the concept of physics is applied, if it is so, then electrons should fall on the nucleus. But till we see that the thing is not happening, so what is the reason behind it, or why there is stability of atom, that cannot be explained by Rutherford. Now the second one is that it cannot explain the spectra in hydrogen and other atom. The origin of the spectra of an atom cannot be explained by Rutherford. Number 3, the electron can revolve around in a circular path, we know it, but there is possibility of revolving electron in this way, oval shape. So it cannot be explained by Rutherford. Why not oval? Why it is circular path? So these are the some of the drawbacks of Rutherford atomic model. All point which I have missed out, that during the Balmer series, 11 series, Balmer phone series and bracket series we have explained in the last class, you see there is often a question in the entrance or in the class is asked that when electron jumps from, we know that we have explained the spectra in hydrogen. Okay, so we see when from excited state of the electron comes to the ground state, it lose out energy, and during this energy del E is equal to H is equal to C by lambda, and we see there is fine structure which is examined or analyzed under prism, and this structure is called spectra, and this spectra is due to the electrons jumping from lower level to higher and coming back to the higher to the lower with the evolution of energy. Now question very often asks, say if it is 6 level, energy level is 6, and it is coming to the ground state, energy level is equal to 1. So very often question asks from 4 to 5, 4 to 1, 6 to 1, this to 1. if electron jumps from that level to that level, what will be the number of the spectral line appears. So at that time you may be confused how to find out. Very often question is asked, answer number of spectral line is equal to n into n minus 1 divided by 2. Here it is jumping from n6 to n1. Am I right? So here n is equal to 6. So there will be 15 spectral lines. So now after, let me come to the first part of today's lecture, is the Rutherford atomic model, and after this we will discuss black body radiation. So it is seen that just I am showing you defining the black body radiation. When a solid is heated, its emit radiations of all frequencies varying from low frequency to high frequency, and the ideal body which absorbs or emits out all the types of the radiation, it is called black body, and the emitted radiations coming out from the black body is called black body radiation. Why I am taking this concept, you will understand Planck's theory of radiation. In Planck's theory of radiation, it is very important. It is very often asked in the exam, and the theory is very applicable, very important and applicable in all aspects, and very often you use the formula by you, but we don't know how this concept or the formula has arrived, where from the formula has arrived from. So already we have seen that when the radiation from a black body emits out. Am I right? So what is the nature and how it emits out, and the nature and the way to emits out from the radiation from black body was explained by Planck. Am I right? The radiations which are emitted out from the black body, the way they emitted out is explained by Planck's theory. Am I right? Planck readily explains the way as to how the radiations of black body emitted out, and that theory is called Planck's theory. Am I right? So Planck tells that so Planck tells that the radiations emitted out from the black body is discontinuous. It is not a continuous, discontinuous. It is discrete in the form of packet of energy. In the form of packet of energy, new concept of quantum mechanics, and this packet of energy is termed as quanta. And in case of light, if it is emitted out from light radiation, that quanta is replaced by photon. So quanta and photon are the same and applied in different field. Am I right? So both are radiations. So quantum and this. So according to Planck, what it tells is that energy emitted out from black body is nothing but is proportional to the frequency. Am I right? And this energy is equal to some constant into frequency, and this H is the Planck constant, you know it. Planck constants, and value is equal to 6.314 into 10 minus 34 joules second. You know it very well, each and everybody of you know. The value is 6 into 10 to the minus 34 joule second. Am I right? So this is the expression of the emitted energy is equal to h nu, where h nu is equal to nu is equal to c by lambda. Again you know it. Again e is equal to c in 1 by lambda, and 1 by lambda is equal to, again you know, wave number. In various form you can take it if you have the knowledge of this. So maximum of the fact in the Bose theory will explain this Planck constant, Planck's formulation, and then you can realize that where from the concept is equal to h nu has arrived at. It has come from the black body irradiations, and it is called Planck's irradiation theory, Planck's theory of irradiation. So packet of energy, discrete packet of energy is called quantum, and in case of the light radiation it is called photon. Am I right? So E is proportional to frequency is equal to h, some constant h nu is equal to nu is equal to c by lambda, or h is equal to 1 by lambda, 1 by lambda is equal to nu bar. So nu bar is equal to wave number, h into nu bar. Again, the number of the packet of the energy is emitting out is equal to n into h nu. Number of the energy emitting out from the emitted radiation is equal to E is equal to nh into nu, where n is equal to 1, 2, 3. Keep it in your mind. Very often ask the number of the radiations emitting out. So this is all about black body and Planck's theory. Now again, very important concept, and if please minutely follow this concept, again it will be wave nature, wave theory, dual nature of wave. You will find in physics the first atomic physics. Before that it is this chapter. Again you will get photoelectric concept. So minutely follow, it will be very helpful in this one. Very often in entrance exam, in the last, not 2024, 2023, there is a question from Planck's photoelectric effect. So minutely follow what is photoelectric effect. Some of the very important application, important terms which will be used in the later on when I will derive in Einstein photoelectric equations, and I'll explain all these terms. So first of all, you first know what is photoelectric effect. Photoelectric effect I have not shown for time point of for saving the time. I have not given you the structure of the experiment. There is a tube in a vacuum tube in which the voltage is applied upon this one, and lots of things are there. I am not showing this one. There is plate and voltage is there. Out of this metal plate, a light from this, in this way light is fall upon the plate and electrons ejected out from this one. When electron, a lot of arrangements are there. I am not showing you this. You will get it in physics in the first class of physics chapter I have in second year. I have started to. Please go through and you will get the photoelectric in a very elaborate way, but this elaboration is not needed in the first year. Till I will explain whatever is needed up to your level and to make your concept clear. So you see, when a light of suitable frequency, that is nu naught frequency, nu naught, fall on the surface of a metal, the electrons emitted out of the metal surface, and the current produced out of the flow of the electron is called photoelectric current. That is, when a light of suitable wavelength, not all wavelengths, light of suitable wavelength is made to pass on the metal surface, so electrons starts ejecting out from the surface of the metal. When there is the flow of electron, what's happened? There is flow of the current. So this flow of the current is called photoelectric current. Now what's happened? Another technique is that if you reduce the voltage, negative, the voltage reduces. So as soon as you reduce the voltage, the ejection of electron will, number of the ejection of electron will reduce and reduce, small and small and small, and one time will come for the reduction of the potential, thus electric current will become nil, that is ejection will become nil, and the potential for which electric current, photoelectric current becomes nil or ejection of electron becomes nil is called stopping potential. You will get it later on Z naught in physics class. So that is called stopping potential. Another important point is that is new frequency nu naught. What is the special name? Another name of this one is that the minimum frequency nu naught responsible for the ejection of the electron from the metal surface is called threshold frequency. The frequency for which the electron is possible, the frequency of light which when fall upon the nuclear surface, ejection of the electron occurs, and that frequency is called nu naught, is called threshold frequency. So we know nu is equal to c by lambda, am I right? So nu is related to lambda, that is in terms of lambda you will tell that if a minimum wavelength of light which when fall upon the metal surface, again ejection of the electron may occur, and this minimum wavelength lambda naught is again termed as threshold wavelength. So we see each and every metal has a specific nu naught threshold frequency, and each and every metal has a specific targeted given value of lambda naught threshold frequency and threshold wavelength, from which this ejection of electron the light with that frequency or that wavelength when falls upon the metal surface, ejection of electron may occur. Now what practically happens, and out of this Einstein equation, photoelectric equation, we will explain. So before writing the Einstein photoelectric equation, let us first explain some of the facts. Just to see, this is the light with energy h nu is made to fall upon the surface of the metal. Then what's happened? That lights when fall upon the metal surface, so the electron starts moving with some amount of energy. That energy is called kinetic energy. When the energy, the motion is there, that is called kinetic energy. Am I right? So it starts moving. So the electron which breaks the metal bonding, the electron which can breaks this bonding, if can break, that electron will escapes out. That is called ejection of electron. So what's happened? The energy which you have supplied is now is now uh, is now divided into two parts. One part is equal to work. A work has been done. That is I have forgotten. H nu naught is equal to work, and that is called work function. H nu naught, Planck constant nu naught is work function. So some amount of work is done, and that is called work function. And that work function, and due to this, there is increase in energy movement of the electron, starts rotating here and there, and sometimes it's go away from the metal surface, escapes out, ejection. And this energy which you have supplied upon the metal surface is splitting into two parts. One is work function in terms of work and making energy of kinetic energy, and other is ejecting out. Um, um, Two things you are getting. One is kinetic energy, other is work function. That is H nu is equal to work function is equal to H nu naught, means the specific frequency is required, otherwise the electron will not come out. So that Planck constant H into specific nu naught gives you work function, that is work function equal to kinetic energy. Now if you just arrange it in this way, H nu minus H nu naught is equal to kinetic energy, or further on C by lambda is equal to C by lambda naught is equal to kinetic energy, or in the better way you can write it in this way, that is H.Sc 1 by lambda minus 1 by lambda naught is equal to kinetic energy equal to half mb square. Okay, you will get a lot of the formations of Einstein photoelectric equation. The first one is H nu H E H H, the line which is made to the light which is made to the energy which is made to, this is energy which is made to fall upon the metal surface is divided into part H nu naught plus this, and sometimes it is phi naught as work function of it is used in physics. You will get phi naught work function, that is H nu naught equal to H nu is equal to H nu naught plus kinetic energy H nu minus, just I have taken this into this side and simple calculation I have done. So I have got H is equal to 1 by lambda equal to, we know the value of H, value of C, light, velocity of light, and lambda, it will supply to you whatever is asked in the question. You can explain with the help of calculate it out with the help of this equation. This is photoelectric effect. Now there are some very important questions very often asked in the exam is so number one, that more and more number of electron you should, if you want to eject it out from the metal surface, so what you need to do is the number of the electron ejected out from the metal surface is dependent on the intensity of the light, incident light, intensity of incident light, incident light. So if the intensity of the incident light is more, then more or more electron will be ejected out. Sometimes the option in options it is given the number of photoelectron emitted will be increased. The help of frequency with the lambda will have this with the energy like this. Again, kinetic energy is dependent on the frequency of the incident radiation. So if the frequency is made more and more bigger, higher and higher value of frequency is more, the kinetic energy will increase. So these are the two very important points very often asked in the entrance. Let me explain first postulates of the Bohr's atomic model. He has given some postulates, and very often from the postulated question asked in the entrance and also in the class exam. So I need to follow the postulate. The first postulate, the whole mass is concentrated in the center of the atom, and it is the same as proposed by the other four. Means there is a positively charged particle is residing at the center, and this positively charged particle along with the center other material is responsible for the whole mass. It is the first postulate of the Bohr, and it is the restoration of Rutherford's model. Number two, the electrons revolves in a circular path in a certain permitted orbit. Means electron cannot revolve in any orbit it desires. Means there are some permitted orbit in which electron can revolve. In elaborate next two postulates, I will explain this part. Ordinarily, electron continues to revolve in a stationary states or orbit. That means electron whenever revolves in a permitted orbits, the orbit, given orbit, how it is given I will tell. In a given orbit, then this given orbit must be stationary, means it is fixed. It doesn't have more or less energy. There is no question of emitting out or absorbing electron energy. Am I right? With the energy which is required, if this with this energy the electron revolve with this state, the energy of this state, these are the different states. Say it has say for example 5 joule energy, electron volt or joule, whatever is there. This is 6, 7 and 8. If the one electron has 5 joule or 5 electron volt of energy, it is permitted. It is permissible to revolve only in this orbit. If it is has this amount of second orbit, it is has this amount third orbit. Means this orbital has fixed amount of energy. It is fixed, and these energy states are called stationary states. Means when from the nucleus you will go away from the far and far, energy will increase, E1, E2, E3. So orbital energy will be increased. So this orbital has fixed amount of energy, and electron revolves in the fixed amount of energy levels. Am I right? So there is no question of losing out of energy as proposed according to classical physics. We thought that we are taught that when electron revolves in a circular path, it would have lose energy. No, there is no question, because energy is fixed. There is no question of losing out energy, and this is a very important postulate, and which has overcome the drawbacks of the Rutherford. Am I right? Number 4 and 5 are very important. You minutely follow. One is very often some of you learn by heart, and very often you may not know the main mechanism or part or the explanation as to how this happens. Only those orbital, only those electron in, I am not writing, only those Now, let me explain. Only those electrons in an orbit can revolve around the nucleus in a circular path whose angular momentum is an integral multiple of nh by twice pi. This is r, this is electron, and its velocity and its mass. When it is moving in this direction, so it is making an angle in each and every points. So momentum is equal to mv, and with angle arising out from radius is ambr. This is angular momentum designated by L. So during the revolution of electron around the nucleus, there is an angular momentum, and this angular momentum is found to be n into h by twice pi. The fact lies here is that here it is h is a constant, 2 pi is again constant, a constant term is multiple by n, where that n is equal to 1, 2, 3 dot. So why it is called integral multiple of n, integral multiple of n into h by twice pi. Integral multiple of n means the value of n must be 1 to not in between 1 to 1.25, 1.35, 1.56. A crore and crore numbers or fractional numbers are there in between 1, 2, 2, 3, 2, 4, 5, 6, 7, 8. No values of n except 1 to whole number value or natural number value is allowed. No in between number or fractional value is allowed. So only those electrons can revolve in a circular path. Only those electrons can revolve in an orbit in a circular path around the nucleus, whose angular momentum is an integral multiple of 1, multiple of 2, multiple of 3 of h by constant. A constant term should be multiplied by 1, 2, 3. Now what is the question? Now if we multiply this value with 1, you are getting one value, with 2 you are getting one value, with 3 you are getting another value, 4 another, 5 another. So with this 1 to a value of n, 1, 2, 3, the value which you get with this value, electron can revolve only in the circular path. Now if you put the value in between 1, 2 or 2, 3, any fractional value, with the value which will come out with that value of electron cannot make an angular momentum and cannot rotate. Why? Because there is a question that when electron revolves in a circular path around nucleus, so what's happened? It makes an wave. Am I right? Say it starts from here and ends again here, again starts from it continuing. So means again I am showing you another situation where electron starts moving in this way. It is started here and out of phase. It is out of phase. It is in phase. Now what's happened? When you put the value angular momentum, the n, the value of n is equal to 1, 2, 3, and if you put, then you will find from here it starts and it's go on getting in a wave. The wave will continue. In same phase, wave will continue. But when you put the value of n in between 1, 2 or 2 or 3, you will get a value. When electron starts moving in this way, the point from where it starts, it will not continue, it will go away. Means it will be in different phase. It will no longer will be in the orbit. So that's why it is told only those electrons can revolve in the circular path around the nucleus whose angular momentum is integral multiple of n into h by twice pi, where n is equal to 1, 2, 3, not in between these two. This is the reason. I could have derived the formula how we have got this one, but it is out of your scope. I am not going in details. The next important point is again very important, postulates very often asked in the entrance, so also in the class. You see, when electron jumps from one orbit to another orbit, from the ground state to excited state, when ground state to excited states, on absorbing energy, am I right? N is equal to 1, n is equal to 2, say, am I right? On absorbing some amount of energy, it moves that level to another level. Again, it comes back to the initial position by losing out energy. And that energy is equal to called del E. Del E is equal to E2 minus E2 minus E2 minus E1. Am I right? E2 minus E1. And according to Planck, what we know, it here energy is equal to H nu. That H nu is equal to C by lambda. Am I right? So in Bohr's that postulate, it is mentioned when electron jumps from the lower energy level to higher energy level, it comes back to its initial position by losing out some amount of energy, and that amount of energy is equal to del E, and that del E is equal to nothing but Hc by lambda or H nu. This is all about the concept of Bohr's postulates of Bohr's atoms, which has in a very large extent explained the inability of Rutherford, who couldn't explain some of the facts. Now let us explain some of the drawbacks of Bohr. Drawback of Bohr. Now, what are drawbacks? Bohr, first of all, Bohr could explain the spectra of hydrogen single electron atom. Could explain spectra of single electron system like hydrogen, helium, lithium, like this single electron system he could have, but he couldn't explain the spectra of multi-electron system, could not explain the spectra of multi-electron system. Am I right? How spectra in multi-electron system, more than 2 electron, 3, 4 electron, how the spectra occurs, the explanation could not be given by Bohr. Number 2, it is found that the spectra which you analyze in the prism, which if you place this spectra in magnetic field, then it is found that this spectra already analyzed in the magnetic in the prism is again splitted in a group of spectra, and this splitting of the spectra in presence of magnetic field is called Zeeman effect. Z-E-E-M-A-N, Zeeman effect could not be explained by Bohr. Why this happens? Also, splitting of spectral lines in presence of electric field means it is called Stark effect. Stark effect means when the spectra is placed in electric field, again like as magnetic field, there is splitting of the spectral lines, further splitting. And why this further splitting of the spectral lines occurs in presence of electric field, that could not be explained by the Bohr. That is, Stark effect also could not be explained by Bohr. So we have shown that these are the very important three factors which could not be explained by the board. Again, another some factors I am for your knowledge, big huge knowledge. Just I am showing you that it unable to explain dual nature of the matter. In later part, when de Broglie hypothesis will go to this, each and every matter has two nature. One is particle nature, other is wave nature, and these two nature, that is dual nature of the matter, could not be explained by the board. And second, unable to explain uncertainty principle. Heisenberg uncertainty principle will coming to the next class. Again, that could also be could not be explained by board. Again, no conclusion was given to the quantization of energy. We have already seen energy is in discrete from packet of energy is called quanta, and in terms of the light radiation it is called photon. This continuous emission of energy, that is packet of discrete amount of energy, is quanta concept. On this he is silent, he couldn't explain the reason, and hence no conclusion was given to the quantization of energy by Bohr. These are the some facts of the metal structure. Then Bohr and Sommerfeld model is there. I think it is not in your syllabus, it is out of your scope. Hope you have understood the class with utmost interest. In my next class I am going to start with de Broglie's hypothesis and quantum Schrödinger wave equation, and now also Heisenberg's uncertainty principles and spin quantum numbers. Very often question asked and very exciting class I'm going to start in the within few days. Hope you have understood the class. Please don't forget to subscribe and let others to enjoy the class.